V1 means all along the journey, the first body keep its velocity always a constant because it covers equal distances in equal intervals of time. The other one is also doing the same thing. Velocities are uh, constant, but V1 may not be equal to V2. V1 is not equal to V2, right? But V1 is constant, V2 is also constant. So this is so for first body we can write xt is equal to x1 t, sorry, x1 t is that means the position of the body when time t is x1 t is equal to x10 initial position of the first body plus v1 into t. Right? When a body moves with uniform velocity, then displacement is equal to velocity into time plus the initial displacement of the from the origin. This is the expression for a body with a uniform velocity. So for this one, we can write what? This is x2t is equal to x20 plus v2 into t also. This is the second body equation. These two equations when we have, suppose this is subtracted from this equation, we will get x1t. I am writing x1t minus x2t is equal to x10 minus x20 minus x20 again plus what v1t minus v2t, that is equal to v1 minus v2 into t we can write. So this is the expression. So three terms are there in this expression. x1t minus x2t is the relative positions of the body when the time is t seconds. Relative positions. And x10 minus x20 is the relative positions of the body when it was initial and at the initial condition. When time t is equal to 0, both were having a distance difference. This is better. Near to the this one, there is a distance difference was there. Both are moving right like this, like this, like this, like this, like this, like this. Right? One is ahead and other is just behind them. So there is always a distance difference between these two. X1 it is greater and x2 it is lesser. Distance difference is there because there is difference in velocity. Am I correct? In this case, this is the relative position of the body when time is t seconds. Okay. This is the relative positions of the two bodies when the time is equal to 0 seconds. Then when just you open your eye, both the bodies started from two positions initially. One's position was x10, other position is x20. So there was a relative position, right? Difference in position initially also. And the other one, v1 minus v2, is called relative velocity. So in this case, we can write v12 is equal, that is v12 is equal to v1 minus v2, we will write. So velocity of one body added with the negative velocity of the other. This is what is called relative velocity, right? Now position vectors of the two bodies when moving with the two different uniform velocities, how we can draw the position time graphs. Position time graph I am going to draw here. That is also very simple position vectors, right? Two bodies are traveling and the data is collected from the ground. Data is collected, and for the two bodies, a graph is made like this. Right? This is for one body, first body. This is for the second body. This is for body 1, and this is for body 2. Right? This is velocity v1. This is velocity v2. This is x10, and this is x20. Position, and this is velocity. Right? So, sorry, this is time, and this is 0. So when the position time graph is made for two bodies, if they are parallel, when two lines are parallel like this, then their slopes are same. Slopes are same means the velocities are same because slope of a velocity position time graph is called velocity. In this case, these two position time graphs are parallel to each other. Therefore, slope is same. Slope same means their velocities are same. So two bodies, when they are moving in parallel lines or on the same line itself, right? Suppose there is a line here. One body starting from this point, other body starting from this point. Both are moving. And final also, when they reach at the final points, there will be a difference in the positions, right? And because they are traveling with a different uniform velocities, right? So when two bodies are having the velocity same, and also they are moving the same straight line, the distance between the two bodies will be same at every instant. Same at every instant. That is why they are parallel to each other. So position times of the two bodies are parallel to each other. We can say that the velocities are same. That is V1 is equal to V2. Or V1 by V2 is equal to 1. V1 by V2 is equal to 1, we can write. Right? This is one condition. Suppose that in a case if this is the situation. The two bodies are traveling in the same straight line, and one is like this, and the other is like this. This is V1 and this is V2. In this case, when these two velocities are, this is x10 and this is x20. X10 and x20, you know, it's a position. This is time and this is position. This is 0. At the 0 time, the first body has a distance from the origin is equal to x10. At t is equal to 0, the position of the second body away from the origin is equal to x20. This is the initial position, initial relative positions. Right? Now the bodies are moving with the different velocities. But for each body, the velocity always remains a constant. But between these two bodies, there will be difference in the values. One may be more and other may be less. In this case, both were same. In this case, you see the slope of, when you compare these two lines, which will have more slope? This will have more slope. And this is more parallel to the time axis. Therefore, the slope of this is greater and this is less. That means V1 minus V2 is less than 1. We can write, this is the case, V1 by V2 is less than 1. That is, V1 is less than V2. That is the position vector of two bodies moving with the constant velocities, but one velocity is greater than the other. Which one is greater? V2 is greater than V1. Then this is the position vector of those two bodies. Right? If V1 is greater than V2, how can you draw that? If V1 is greater than V2, then we can draw like this. This is one graph and this is another graph. This is V1 and this is V2. This one is x10 and this is x20. Right? In this case, we can write what? V1 by V2 is greater than 1 or V1 is greater than V1. So this is the position, this is time, and this is 0, and this is position, etc. From the graphs itself, you will note down all these things on your paper. That can make a beautiful notes for you, right? And also you have a textbook that you will refer that textbook also, right? That also you can do. So when two bodies are moving in the same direction, more thing what I want to tell is, when two bodies are moving with the same moving in the same direction, then the relative velocity is equal to V1 minus V2. V1 minus V2. When two bodies are moving in the opposite directions, then the relative velocity is equal to V1 plus minus V1 minus of minus V2. Always V1 minus V2, right? First case, both the bodies are moving in the same direction. Then relative velocity is equal to V1 minus V2. Okay. In the second case, bodies are moving opposite direction. One body is moving in this direction, other body is moving along the other direction. This is V1 and this is V2. So here relative velocity is equal to V1 minus of minus V2, you will write. Then this is equal to V1 plus V2. So these two things you will remember. When two bodies are moving in the same direction along two parallel lines, okay, with the different velocities, but individually for a particular body, the velocity remains a constant because both are executing uniform motion. Uniform motion means bodies move the constant velocity. Such motion is called uniform velocity motion. So when two bodies are moving in the same direction, then relative velocity is equal to V1 minus V2 or V2 minus V1. V1 minus V2 means relative velocity of body 1 with respect to body 2. V21 is equal to V2 minus V1. That is relative velocity of body 2 with respect to the body 1. So V1 to V21, you know the meaning of that. So then what you see is the next case what we apply is that suppose the two bodies are not moving in parallel lines, but makes an angle theta between them. Then what will be the relation? That only I am going to tell you now. That is this. The two bodies are moving with different velocities, and these velocity vectors are make an angle theta between them. Then what is the relative velocity? How can you calculate the relative velocity? That is this thing. Suppose this is VA and this is VB, and they are making angle theta with, right? What we want to calculate is the relative velocity of A with respect to B. That only we wish to calculate. So the relative velocity of one body with respect to other is the velocity of the first body minus of the velocity of the next body, right? But we don't have minus VB. Minus VB is not there. When minus VB is not there, we have to create the negative vector of B that is drawn along the same direction. Now, this is what is called minus VB mark, because we want to calculate VA minus VB. VA is there and plus VB is there, but we don't have minus VB. Minus VB can be obtained by projecting the velocity VB in the opposite direction with the same length and also in the same direction, opposite direction. In the opposite direction with the same magnitude, if you make another vector that is equal to minus VB. Now make this parallelogram complete. This parallelogram is completed, right? So two velocities are the two vectors are adjusted by the two adjacent sides of the parallelogram. Then the resultant of these two vectors is obtained by the diagonal of the parallelogram. This is diagonal. So what we get is this is vector VA plus minus vector VB we are getting at. This is equal to VA minus VB. Vector VA minus vector VB. We got it. Am I correct? Suppose this angle is theta. Then what is the angle between VA and minus VB? That is equal to 180 minus